Buenas tardes, bienvenidos a nuestro Renewable Tuesday. Soy el ingeniero Juan Boada de la División de Energía Renovable de Glen International. En el día de hoy vamos a estar presentando los sistemas de racking para los paneles solares de IronRidge. En esta ocasión queremos explicarles que toda la naturaleza de estas presentaciones son que todas las preguntas nos las hagan a través del chat para nosotros poder ir contestándolas, y de las que no tengamos las podemos pasar donde nuestro presentador. Ya en el día de hoy vamos a estar trabajando y presentando los sistemas de IronRidge, como antes mencionado, y vamos a tener nuestro presentador, a John Ham, que es el Senior Technical Product Support Representative, y también tenemos como backup a Glenn Woodruff y a Carlos Maldonado de Support y Training de IronRidge. ¿No? La División de Energía Renovable de Glen International.
Okay, so am I good to go here? I just have on full screen, so I can't see if my presentation's on full screen, so I can't see the other part of it. Okay, so I'll just go ahead and start here. Hopefully everything is good. So my name is John Hamey. I'm a senior technical support for IronRidge. And I've been in this for over 27 years in the solar industry, and 17 years as a contractor, installer, and licensed electrician. And I'm been NABCEP certified since it first began in 2003. And I'm been with a technical support for, excuse me, 2 different PV module manufacturers for 2 years or 7.5 years. Speak for you. Carlos also works in technical support with IronRidge, and he came over from the quick mount side. He's been in the industry a long time. He's also NABCEP certified, and he can speak Spanish. So if we have any questions in Spanish, Carlos will help us out.
Be happy to help.
Oh, there you are. So I didn't know you could speak. I would let you introduce yourself. Sorry, Carlos. So today we're going to cover IronRidge. I'll do a quick intro to IronRidge and the quick mount PV, and we'll go through the IronRidge tilt mount system and components. We'll talk about site conditions and design, go through installation, and then a quick design assistant demo. And if we have time for question and answers, we'll hit that at the end. Oops. So a little brief history. IronRidge was founded by Craig Carney in 1996, and he was an early pioneer in the solar industry. When I was working in solar back in the 1990s, there were no pre-engineered mounting systems. We were making our own out of angle aluminum or unistrut or anything we could find. So Craig was a real instrumental in starting a company IronRidge to build racking systems. IronRidge and Quick Mount are part of the ESDEC family of mounting systems, which also includes EcoFasten and Panel Claw. IronRidge and Quick Mount operate as one business unit, and EcoFasten and Panel Claw are separate business units. IronRidge makes a flush mount system for pitched roofs, the tilt mount system, which is what we'll talk about today, and a ground mount system, and also a ballasted system. So the quick mount products that we carry are the roof attachments for any type of roof. So we have for comp shingles, cedar shakes, steel shingles, slate, tile of any type. So there's many different roof attachments and conduit penetrations that, through our quick mount line, and also standoff posts for low slope roofs. So today we'll talk about the IronRidge tilt mount system and components. So it's really a simple system. You know, we're using the IronRidge XR rail with our with a pair of tilt legs and then the flat roof attachment. So it's a really simple system. It can tilt anywhere from 4 to 30 degrees, and or you could do it as a flush mount without the tilt legs. So the tilt leg kits come in increments of 5. You know, the front leg, the south leg is a 7-inch leg. That's a fixed height. And then the rear leg comes in 10, 15, 20, or 25 or 30-inch lengths. And then we adjust the distance between the north and south tilt leg to fine tune that tilt. And we'll talk about that later. So each kit includes a north and south tilt leg and the hardware for assembling them. So we work with we have a flat roof attachment, which we call the FRA, and it attaches directly to flat roofs with no rafter required. It's a 16-point fastening pattern for range of design options. And we have site-specific structural engineering, which would be required for the fasteners, and we'll talk about that a little more in detail later. And this is compatible with the most common low slope roofing materials. And we also have a membrane, to seal that. We also offer the Q-base low slope standoffs that work with our tilt mount system and available in 8 different post heights. And so this can work especially where you have to core out insulation to get down to the roof deck. But it also can work where you want to elevate your system a little higher. So IronRidge has 3 different size rails. The XR1000 being the largest rail we have, the XR100 in the medium range, and XR10 for budget, the smaller spans. So we, in our design tool, will show you which span would be the best for your project, but we have options. And this curved shape adds strength in both directions. So not only vertically, but horizontally, laterally, it adds strength to the rail. So now we have a new splice as well. So if you were familiar with our old splice, it used to have to use 4 tech screws. And so we've done away with those screws, which people were losing all the time, or they'd fall out of your hand when you're trying to put them in and roll down in the gutter or off the roof. This new Boss splice just inserts in the rail, and you push them together, and it works great. And it can also be used as an expansion joint if you leave a gap, and it has bonding and grounding with the teeth that are built in that spring. So one of the benefits of this, the old splice rules, you could not splice in the center of a span or near the last span in a row. So now with the new Boss splice, the only place you can't splice is in the cantilever past the last attachment, but anywhere else is okay to splice. So that simplifies the splicing of the rail. So our module attachment clamp is what we call a UFO, or Universal Fastening Object, and it fits module frames from 30 to 46 millimeters thick. And we have stopper sleeves that turn that into an end clamp available, and you need to get the stopper sleeve that fits the module frame that you're working with. So also the ground lug to finish the system, you need just 1 ground lug per row, and it can rotate in either direction, and it's a low profile, can be underneath the modules. We also have a micro inverter optimizer kit And this is compatible with Enphase, SolarEdge, AP Systems, Starfon, Tigo, and SMA microinverters or optimizers. And it's just a T-bolt kit that attaches the microinverter to the rail. So we'll talk about site conditions and design considerations here. Flat roofs vary in construction. I know in Puerto Rico, concrete roofs are the most common method or type of roof there for flat roofs. But there are many different types with metal roofs and metal framing, metal decking, and there's the older buildings with wood framing and decking. So, and insulation can vary in thickness. All these things affect your design for tilt mount attached system. We'll also consider wind loads. I know there's no snow in Puerto Rico, but the wind loads are certainly a consideration with being in a hurricane prone area. I know too that the code was adopted for 2018 International Building Code in Puerto Rico. So that means that it references ASCE 7-16 for references to the code. And so I will talk about the difference between ASCE 710 and 716 as they apply to the tilt mount system. So for one, the wind speed maps changed, and it divided up the categories a little bit more finely in 716. And there are special case study zones. So if you're in a mountainous area, you may need to check whether you're in the valley or up on the ridge as to how that affects the wind speed recommended for use in your area. So also on flat roofs, you have to be aware of how wind flowing over the roof affects solar design. And so the roof edges are more subject to high suction effects from vortices. And so this is something that we can take into consideration in our design. We use wind maps or wind tunnel studies in our ballasted system, but this is also something that is important to understand how wind flows over a flat roof. So the other thing to consider in design is the height of the building. So if it's a lower building, that's not going to change the wind speed much, but you can see as the height of the building increases, that increases the wind speed for the design of the system. And then in seismic zones is another consideration, and particularly the height of the building and how it affects movement. So something to understand is that our design tool takes into consideration all of these things: building height, seismic zones, wind speed, roof zones, so that when we get into the design tool, you can see how we're helping you to design a system that's going to stay in place for the site conditions that you have. So roof zones, basically, it's a determination based on the height of the building, but the main takeaway here is that zone 1 is the middle of the roof, that white zone where most of your solar panels go. But zone 2 is the yellow area there, and zone 3 is the red areas, the corners. So the edges and the corners are subject to higher wind speeds. And so this is important to understand in designing a system. So in ASCE 716, they've added a new consideration that wasn't there in 710 for exposed modules. So this means that if you're closer to the edge and there's more than a 4-foot gap between modules, if there's more than a 4-foot gap between modules, then modules on either side are considered an exposed module. And also half the distance or half the height of the roof, no module within 4 feet of the edge. So that these are considerations and we will give in our design tool whether your module is considered an exposed module or an edge module, and how that affects the spans in the design tool. So this is an example in our design tool where it shows the normal spans in each roof zone, but it also shows the exposed modules and how whether or not that changes the span. In this example, the spans have not changed, but the uplift has changed. So you notice that the reaction forces on the right there, which are the down force, the uplift, the lateral, and the moment, the uplift has increased in the exposed area where all the other values are the same. So this can affect the capacity, or what it means that the capacity of your attachment needs to be considered for this uplift force. So also with the tilt mount system, you need to consider, the tilt angle. The higher the tilt angle, the more space you need between rows to prevent shading on the row behind. So there's some complicated math here to figure that out, but there also are some online tools from third parties for calculating row spacing. So the flat roof attachment, we do not provide the screws to the attachment to the roof because there are so many different roof types. So our flat roof attachment can handle a screw diameter of 1/4 inch or a number 15 screw. And there are 16 holes there. 4 of those are angled and the rest are straight down. And depending on the type of roof you have, you need to evaluate or have the engineer of record specify how many screws and how long they need to be and what type they need to be for your given roof situation. And as I pointed out earlier, the reaction forces are what would tell the engineer what capacity he needs to meet. And then he just needs to specify based on the roof construction. So I know in Puerto Rico, there's a lot of concrete roofs. So, on the bottom there's a couple of concrete type fasteners that would typically be used. And as I said, the reaction forces per attachment are listed in our design tool, and that's what you need to know. So when you increase the spans between attachments, you're increasing the force on each individual attachment. So in a high wind zone like Puerto Rico, you may need to have closer spans to keep those reaction forces within the limits of the capacity of the fasteners you're using. So other types of roofs, there's TPO or PVC, KEE, EPDM, or asphalt type roofs. So those we can handle or use our flat roof attachment on any of these types of roofs. It's best to partner with a roofer to understand if you're using a membrane type roof, to evaluate the roof and also help with sealing the roof. That way you can maintain the roof warranty. Or if you're doing it yourself, just to understand the construction of the roof is really important. So if you're using our flashing membrane, these are for use with membrane type roofs like TPO or PVC or KEE. We work with different manufacturers that are listed here. These are the ones we stock for GAF, Firestone, Carlisle, Sarnafil, and Mulehide, and John Mansville. We can get other types of membrane flashings on special order. They would be a minimum 800 piece order, so it has to be a larger project to do that. The other option is to use a third-party product called ChemLink eCurb, and this is a two-part or single-part silicon sealant, and you build a little dam around it, that curb piece, and then pour in the sealant, and it forms a perfect seal for your roof. This is a simple and easy way to do it. It works well, particularly if you're using the Q-base product, because that's not as wide of a diameter. I think it's only a 4-inch base versus our flat roof attachment, which is a 7-inch base. So let's go through some of the installation here. So basically, you're going to mark your positions for where you're going to put your attachments. So you need to run chalk lines across your roof, make sure everything's straight and square and measured properly. And then you want to have a clean roof surface where you're applying the flat roof attachment. And this could apply whether it's on a membrane or a concrete roof. And then you're going to place a bead of sealant on the underside of it. Typically, ChemLink makes an M1 sealant that works well. And then you're going to mark and install your fasteners. And then if you're using the membrane to seal it, there is a removable backing silicone washer on the top. You need to remove the cover from that. And then you place the membrane over it and stick the bolt in there to keep it centered. And then you would heat weld that to the membrane. And typically, like I said, it's good to partner with a roofer to do this. And then you repeat that on all of the roof attachments. Another option for sealing, and this might work well on a concrete roof, is that what we call a 3-course method. And here you can use a compatible roof sealant and a reinforcing fabric, which could be a fiberglass mesh type fabric. And you're doing a coating of sealant, lay in the reinforcing fabric, and then more sealant on top of that. And it gives you a perfect seal. This is very common in the roofing industry for sealing penetrations. So if you're using so with the tilt legs, this would be installing the south tilt leg. And it's not really necessary to use a sealant in the hole because that hole is captured by doesn't go all the way through, but it does help with the sealant so the water doesn't get in behind the membrane. So if you're using a membrane, and then you need to place the washer that comes with that over top of the membrane, and then lay the tilt leg over it, and then put the bolt in and tighten it to 250 inch-pounds. So there is a markings on the south tilt leg. So the tilt angle that you selected, you're going to adjust to that tilt angle and make sure that you've got everything facing the right way. And then you're going to loosely install the 1-inch bolt on the pivot bracket and make sure that the pivot brackets are facing the north tilt legs. So make sure that everything is in the correct position. So you want the rail will face towards the north tilt legs in this system. And so that's how you can see that on the left-hand side there in gold color. So the north tilt legs are similar, that you would place the washer over the hole, place the U-foot over the washer, and then thread in the bolt and tighten that to 250 inch-pounds. And then you bring in the tilt leg and connect with the 2.5-inch bolt and washer. And you don't want to fully tighten that. You just want to have some slight play so that you can move that back and forth as you're adjusting the rails. So then you're going to put in the square bolt at the top slot and then assemble all of the tilt legs before assembling the rails. So here again, the rail can be attached on either side of the north tilt leg. It doesn't matter. It's just the south leg that needs to face towards the north. And you want to match the angle of the south tilt leg so that the top of those rails are flush when the rail's sitting on top. So to attach the rail, you're going to slide the rail through with the square bolts, and then adjust the rail to achieve the desired rail cantilever on the ends. And then you do both north and south rails, and then you're going to tighten those to 250 inch-pounds. So now this is where you attach, and after you have the rails attached, then you want to place a straight edge across the rails. Another piece of rail will work, and make sure that you have the angle correct, and also that it's flat across the top, so that both rail, so that a module frame sitting on top of the rails will sit flat and pull up the UFO correctly. And then you're going to tighten, once you have it in place, you tighten the tilt leg hardware to 250 inch-pounds. So now is the point where you want to, if you have microinverters or optimizers, you would attach the equipment to the rail using the microinverter kits, and position the inverter optimizer on the north rail so it's easier to reach later. And then you're going to insert it onto the T-bolt and tighten to 80 inch-pounds. And then it's a good time to do your wire management with if you have the microinverters. So we have rail wire clips that snap into the top of the rail, and you can bundle your connectors together and use as many wire clips as needed to do the job, so that it has a nice clean look. So this is also where you would put your ground lug in. This goes on the top of the rail, and you torque to 80 inch-pounds, place your ground wire in, and then screw to 20 inch-pounds, tighten that. And you want to have one ground lug for every row of modules. It doesn't have to be on every rail, just every row. So this shows the grounding path. The UFO module attachment clamps bond the module frame to the rail. So that's why you only need one ground lug per row. So now we get to the positioning the modules. So you position the first module at least 1 inch from the rail end if you're using the stopper sleeve in UFO. And that's just where you snap the stopper sleeve onto the UFO, fasten the module to the rail using the UFO and stopper sleeve, and then tighten to 80 inch-pounds. And you want to have everything measured up so that the frame is square with the rails. And then you would start using the UFO without the stopper sleeve for your mid clamps. Place that in next to the module, and then come in with your second module, slide it in, complete your wiring connections, and make sure your wires are wire management is done before you place the module down, and then tighten the UFOs to 80 inch-pounds. So always pull up on the modules to make sure that the UFO is engaged. That's a T-bolt, and sometimes if you don't, we like to use a screw an electric driver with a clutch so that you drive the UFO in at a slow speed, so that it tightens down and engages that T-bolt in the rail. But sometimes if the T-bolt was positioned wrong, it can pull up against the bottom of the module frame, and you have to be careful that it feels like it's tight, but it's not really holding anything to the rail. So always check that. And then you can trim your rail after everything is done to the finished product, and install the end caps, and then repeat this process on all the other modules. If this is more typically used on the flush mount on a pitched roof, but you could use it on this as well. As our camo, it's a hidden end clamp, goes underneath, and it allows you to cut the rail flush with the module frame, so that it's an additional that makes it aesthetically pleasing. But also I find that in high wind areas, some people particularly in the Caribbean islands, and I've heard in Puerto Rico, will use both on the ends, use both a camo and a UFO and stopper sleeve as extra insurance, because it's always the end modules that typically will blow off first in a high wind. So if you want, it's, our design will cover it for either individually, but, I have heard of installers doing this as extra insurance. So that's what the finished system looks like. And it's really, a nice clean look, and it allows you access underneath to check for if you need to do any maintenance to the roof. You can inspect the roof, do any patching that's necessary. That's the benefit of this over a ballasted system. So roof coatings and anything can be applied underneath the tilt mount system. So I always encourage everybody to review our installation manual. Prior to installation, it provides the instructions for assembling all the components, and it also has the module compatibility information in there for your when you're getting your permit. So the installation manual is the official UL 2703 document for our ETL listing. So I want to show you how Design Assistant works here, and we'll jump into that. I'm going to switch screens here real quick and jump into Design Assistant here. So oops, what we got here. Okay, so when you go to IronRidge website, the home page, at the top of the page is there are titles for each of the headers for each of our systems. So the pitch roofs, flat roofs. So if you want to access the documents for our system, you would go into this drop-down menu, flat roof documents, and choose that. And that would take you to this page, and you can get the data sheet, tech briefs, warranty, installation manuals, CAD blocks, certification letters, cut sheets, third-party certification letters. Everything is here that you would typically need for permitting or design. And it defaults to the tilt mount system in the first tab. If you're doing the ballasted system, there's another tab for that as well. So then if you want to use our design tool, if you've never used it before, this is where you would select your design tool. For this tilt mount system, it's the attached flat roofs right here, and you would select that. I already have a window open here. If you're familiar with our system and you use the design tool and you create an account, you can go to My Projects right here, and it'll have all of your projects. And this is what that looks like. So you will have a list of all of your projects here with a project ID number. And if you have a question about a project, you can call us, give us this ID number, and we can look it up online and walk through you with it in real time. So that's a really nice option. So I'm going to show you, I started a project here. And so basically, when you first start a project, you're going to put in your address or your zip code, and then you're going to select, it'll take you to this page. And then you can put in whatever project name you want here, and your location will be here. So the ASC code you would need to select here, it defaults to 710, but if you're in Puerto Rico, you're going to select 716. Snow load's not a concern. These numbers are automatically populated based on your location. If you know that your local building department wants you to use a different wind speed, you can change that here, but ultimately it comes down to what the local building department wants. And then if you're selecting for wind exposure, B, so you can always click on this little icon here to get an explanation of what that means. So exposure B are for urban and suburban areas or wooded areas where, there's things that will block the wind somewhat. Exposure C is more open terrain with scattered obstructions, and exposure D would be, you know, unobstructed areas, particularly on the coast, right on the water. So you're going to select your exposure here, your risk category. For residential, it's going to be 2. If it's a commercial building, 3. This tilt mount system is only for flat roofs, so the roof slope is already defaulted to 0 to 7 degrees. That's what we consider a flat roof. Anything over 7 degrees would be considered a pitched roof. Then you would select your module manufacturer and model number here. So it's going to give you a little window here, and you select the module manufacturer, and then it'll give you a drop-down menu to select the model number. If you don't see your module here, it may be that it's not UL listed yet with us. You can unclick this check box here to see a list of all the modules that are in here. We are always testing new modules, so some may have not fully gone through testing yet. And also you can build custom panels here if you need to, if you have an older module that's not supported in our system here, that you can build a custom module as well. And then here you would select the panel finish. If it's clear aluminum or black frame, that would determine the color of the rail and the hardware for the system. And then here's the end clamp. It defaults to UFO and stop receive. If you want camo, you can pick that here. So these yellow warnings are just things to be aware of, that, you know, you may need to check the wind speed with your local authority. Ground snow low is not provided for this area. I don't know if you have any snow in the mountains in Puerto Rico, but I think snow is probably pretty unlikely in your area. So now you would put in the building information, so the building height, and then the building dimensions, north, south, and east, west. So we'll just put in some dimensions here. And then if you have a parapet, you would put that here. And if you don't have a parapet, just put 0. You'll have to have a number in each of these boxes to be able to move on. Rafter spacing, that's more for your own convenience. It doesn't really affect the design too much. And the same with roof deck pullout strength. So if you have a membrane roof, then you're going to select that, you know what, and you know what the roofing material is. Then you're going to select here for TPO, KE, PVC, built up modified bitumen or EPDM. If you're just working on a concrete roof, what I suggest is just say no, and that takes away the roof information, and then you could proceed. Spectral acceleration has to do with the soil conditions in an earthquake zone, and this should default to whatever based on your location that you gave in the project information. You can check with your local building authority if you need to change that. Then once you have everything, you're going to save the roof information. And you'll get this little pop-up explaining what exposed modules are. You can click this and it'll acknowledge that you understand that. And now this is where you select your tilt angle. So you can go anywhere from 0 up to 30 degrees here. So at 0, it's just going to give you, it's going to switch that to L-foot only without the tilt legs. But if you want a tilt legs, then you're going to put that in here. And it gives you a side view of what that looks like. So in portrait, you can see the spacing here is 4'5" for this particular module at this tilt angle. If I change the tilt angle, that changes this spacing here. So be aware of that. So not only will this tilt leg length change, but so will the spacing here. And if you change, this is in portrait now, if you change it to landscape, it's going to change that spacing again, because now you're clamping the modules on the short end, and it needs to be closer together. So portrait is going to give you the most efficient use of the rail. In landscape, you're going to use twice as much rail per module as you do in portrait. So that's important to know. So that is where you select your tilt angle, and the tilt legs are defined by that. And then here is where you put in your arrays. So however many rows you want, and then columns. Columns are the number of modules in a row. So say we want 5 rows of 10 modules each row. And then repeats, it just means that we would have, if you put 2 repeats, it would mean that you would have 2, you would double this essentially. So if you don't really need that unless you're trying to do multiple sets of this. So once you have it what you want there, you can select save, or you can go in and add more. So say you want one row that has, 8 modules. And then let's say if you want to add some in landscape here, and you want one row of, 6 modules in landscape. So you can do that, and it'll give you the bill of materials up here. Will adjust as you make changes here. So it's going to tell you how many modules up here are summarized, and how many attachments, and the approximate cost. And this cost is based on manufacturer's suggested list price. So you need to go to Glenn International for an actual estimate on your bill of materials. So down here under rail spans and forces is where you select your desired span, the number of feet between attachments to the roof that the rail spans, and also which rail you choose. So here it shows you the max span in each roof zone that each of these rails can handle for the wind loads that we gave. So XR10 can span up to 5'4" in zone 1, but the exposed modules in zone 3 are only 3'6". So that's something to consider, and that's beyond what we have for the 4-foot span. So that's why that's in red. So whichever span that you choose, so you could actually, if you don't have anything in this zone 3 that's exposed, you could use XR10 here. So you could switch to XR10 and go with 4-foot spacing, or you could go to longer spacing. So say if you wanted to go with 6-foot spacing, and then go to XR100, you would have exposed modules in zone 2 or 3 would give a warning. But if you don't have any modules in that condition, then you could use 6-foot spacing here. So it's understanding your layout to make sure if you have modules in all of these exposed areas, then you would need to go with a closer spacing, less than 5'4". And here's the reaction forces that I mentioned over here. And particularly what is affected are the lateral and uplift based on whether it's exposed or in the normal conditions and which roof zone we're in. Also, I want to point out that if you have some short rows or sections where you only need 7 feet of rail, you can tell Design Assistant to cut the rail. So basically, if you click on this, it's going to tell you that it'll change the bill of materials. It'll give you a 14-foot rail, but it's assuming that you're going to cut that into 2 pieces for your 2 7-footers. So it's a more efficient way of just making sure that you're not getting extra rail that you don't need. So lastly, then we'll just quickly, I know we're running close on time, so I wanted to show you the bill of materials here. your accessories. If you want wire clips, end caps, and microinverter kits, you would click those and click save. It automatically gets added to the bill of materials here. And then you can take that to your distributor. And this is where you can email them a bill of materials and get a quote. And then also you can download a spreadsheet version of that if you want to edit it, or a PDF version. And you get your project report if you're, for your getting your building permit. And then over here is the certification letter that has an engineer's stamp in there for Puerto Rico. And then the fire rating, the flat roof attachment certification letters, installation manuals, CAD blocks, everything is here that you need for your project. And you can share this with other people. So if you have other people in your company that you want to share this project with, you can share that, or with your distributor. So that's all I really needed to cover there. So I don't know if there's any questions that we have here, but and if you have questions in Spanish, Carlos can help out. And also, if you have any questions, you can always contact us at support@ironridge.com, or give us a call at the 800 number. I believe that is, I didn't put that up there, but it's 800-227-9523, and we can help you out.
Thank you, Glenn. Thank you, John, for your presentations.
Yeah.
If any people have any questions, please, you have the chat for any questions. You mentioned the UL panels, because in the question we have the maximum panels, if they are compatible with IronRidge.
So there's a list of compatible modules in our installation manual, and so they go by model number. And so we've tested quite, pretty much are continuously testing new modules as they come out, but always check the installation manual for compatible modules.
Okay. But this is all for today. Thank you, John. Thank you, all the people of IronRidge. Y nos veremos.
Thank you. You're welcome.
Okay. Bye.
Bye.